Hello everyone, and welcome to the Beginner TEALScript course. Now in this course, you will learn about TEALScript, a new Algorand smart contract language almost identical to TypeScript. This course is designed for developers who have some prior TypeScript or JavaScript experience. If you have zero experience with these languages, I recommend you learn the basics of JavaScript before continuing on with this course. By the end of this video, you'll know how to write a DAO smart contract using TEALScript and integrate the DAO contract to a front end and make a functioning full-stack DAO application on Algorand. Now, the entire course is demonstrated using CodeSpaces, a virtual coding environment on GitHub that allows you to start building without setting up your local environment. Now, for those who want to learn and build locally, there'll be a separate video on how to set up your local machine to build with TealScript. But if you struggle with setting up your local environment, you can always use CodeSpaces to get straight to learning. Now let's dive into the course and become a master in TealScript.
Hey everyone, in this video, I'll be showing you how to set up GitHub CodeSpaces to begin developing on Algorand. In this video, I'll be focusing specifically on our bootcamp repos, but this applies to any repo that has an Algorand dev container, and I'll show you what that means in just a bit. But to start, what you want to do is head on over to our Algorand bootcamp org on GitHub and head to the link of the repository you want to start with. Most people should begin at the beginner level, so I'm going to go ahead and click on github.com/Algorand bootcamp TS beginner EN. Now here, all we need to do to start setting up our environment is click on this green code button, and you should be able to create a workspace. If you don't have that available, make sure you're signed in, because if you're not signed in, you won't be able to create a code space. So I'm going to go ahead and click this plus button. That'll create a new code space. If you've previously created code spaces, you'll see them down here. For this video, I'm going to create a brand new code space. And what this is going to do, it's going to set up a virtual machine in the cloud that has everything you need for Algorand pre-installed on it. So what we'll see here is that this opens up a browser window with VS Code in it. So if you've used VS Code before, this is the exact same VS Code that you've used. However, this time it's running in our browser and connected to our virtual machine in the cloud. Now, what enables this to happen is this .devcontainer.json. This is the file that tells us all of the ports that we're going to be using and what we need to do when we create and start our VM. So as we can see here, our commands are running. We first installed AlgoKit, so that's the first thing that we do to set up our environment. It does this automatically for you, and it only needs to do it once. After it's done installing AlgoKit, then you'll be able to use it to build on Algorand. For those that aren't familiar with AlgoKit, it's basically an all-in-one command line tool that you can use throughout your development journey. You use it to initialize projects, manage dependencies, do some testing, run a local net, all sorts of features that we'll be getting into throughout the bootcamp series. I'll be showing you a little bit about them in this video today. So while this is still running, what I'm going to do is I'm going to open up a new terminal and show you an AlgoKit command. The first AlgoKit command you'll probably want to use is init. So to do so, I'm going to go ahead and run AlgoKit init. And what this will do is it'll give me a bunch of templates I can choose to start my project from. Each template serves a different purpose, but kind of the three main templates that we want to talk about are the Beaker, TealScript, and React. And then the full stack combines Beaker and full stack. The one we care about in this video and for our developer bootcamp is TealScript. TealScript is a relatively new language that allows you to develop contracts in TypeScript. If you're just getting started and you want to learn the best language to develop on Algorand, TealScript is the best option right now. So I'm going to go ahead and choose TealScript. Now, the next thing it's going to do is ask you to name your project. So I'm just going to name this TealScript demo. And what it's going to go ahead and do is not only create my project, but also install my dependencies. So it's going to take a bit to do the npm install. And the nice thing is because this is TypeScript, because TealScript is based in TypeScript, all our dependency management is done directly through npm. So if you've done node development before, web development before, The dependency management is the exact same. And you'll see here that we have our template. And again, if you're familiar with Web 2 development, this should look fairly familiar so far. Before I get into the files, I just want to mention that there are recommended extensions. You don't have to install these. If you're already a developer and you have your preferred extensions, you can install those manually. But I'm going to go ahead and install the extensions that's recommended. And primarily, we just have the extensions for Jest and ESLint. So once we init a project, it'll open up our README. This will talk a little bit how we can use it and the commands we run, but I'm going to show you in this video, so I'm just going to close out. Now, over here on the left is all of our files, and most of these files, so these top level files, are just configuration files, and for getting started, you don't really need to worry about them. If you're familiar with node development, you'll be right at home. There's a package JSON, your package lock, your config for Jest, and your config for ESLint, and then, of course, your config for TypeScript. And all these configs apply to not only our test code, which is written in TypeScript using Jest, but also our contract code. So speaking of our contract code, let's go in and see how that looks. So if we come to this contracts directory and go to TEALScript demo, we can see here our contract. Now remember, when we initialize our project, we set the name to TEALScript demo, and that's where this name is coming from. So by default, your file name and your class name for your contract will be whatever name you give AlgoKit when you instantiate the project. Now let's take a look at this example project or example contract before we continue to some of the other files that we have here in our project. So this file, it looks like a regular TypeScript class because it is. You'll see here that we import contract from Algorand Foundation TEALScript, and then we create a class that extends contract. And then we define two private methods. So we have one method called getSum that just sums two numbers, and then a method called getDifference that will get the difference between two numbers, and it will always subtract the biggest number from the smallest using this ternary expression. So these are two private methods. They are only callable internally within our contract. And then we have our public method. And our public method here is called doMath. And you can see here it takes two numbers and a string operation, and a string that specifies an operation. So the logic here is pretty simple. We simply say, if the operation is sum, then we're going to call getSum. If it's difference, call this getDifference. And if it's not sum or difference, we're going to throw an error. And then finally return our result. So here we can see that we define our methods, we set them to private, we can instantiate variables just like you can in a regular TypeScript function. In fact, all these lines of code are valid TypeScript. If I were to copy and paste this into JS Fiddle, this code would run just fine. So even though this is a contract, we're still running a native TypeScript. And you'll also notice, in addition to the native syntax, we also are leveraging native tooling like tsdoc to document our functions. This will provide useful IntelliSense, but also give us some other features that we'll take a look at in 1 second. So again, contracts TEALScript demo.algo.ts is our contract file. But we also have these two other directories, artifacts and clients. So to actually generate our artifacts and compile our TypeScript contract, what we're going to do is we're going to run the npm run build script. And what this is going to do, if we scroll back up, we can see we run npm run compile contract, which calls TEALScript, passes in our contract, and the directory we want to output artifacts to. And then we also call this generate client function, which takes in one of our artifacts and outputs a client. So let's first focus on these artifacts here in contracts artifacts directory. We can ignore components for now. We'll get to that once we get to our front end section in the bootcamp. But for now, let's focus on these top level artifacts. So the first is an API file. This is a JSON description of all the methods in our contract and what the arguments are. And you'll notice that we have our types and descriptions here that was auto-generated from our types and our method signature and the description that we provided to tsdoc. So we're leveraging tsdoc syntax to generate this API file along with our method signatures we defined. So we can see here we have our one public do math method, and then we also have a public create application method. Now, just generating this alone isn't super useful, so let's talk about our other files. Arguably, the two most important files here are our approval and clear TEAL files. For those that aren't familiar, TEAL is the machine language that the Algorand node executes when executing a smart contract. So when we called our build script, we ran our TypeScript file through TEALScript. So instead of running a TypeScript file through the TypeScript compiler to generate JavaScript, we ran it through the TEALScript compiler to generate TEAL. You don't need to go into the exact details of how this TEAL is generated. The important part here is that our high-level language code and TypeScript resulted in this low-level language code in TEAL. And now we also we have two more files to go, but this is also a very important file. This is a JSON file that includes the API, but also some additional information like our state schema and our source code. We won't need to worry too much about this file, but what it's useful for is generating our client, which I'll talk about in just a second. But one last artifact I want to mention is this source map. This will highlight what line of TEAL maps to what line of TEALScript maps to what program counter in the VM. So this file you shouldn't need to manually use too often, but if you're in a deep debugging session, this can be very helpful. Now, the most important thing for actually interacting with our contract is this clients. So the second part of our build script ran generate client, which called this AlgoKit generate function. And what this does is it generates a TypeScript file with a bunch of lines of code for interacting with our contract. All this code was pre-generated, so we didn't need to write this boilerplate ourselves. And now if we come to the template, take a look at our test file, we can see how that's actually used. We import the demo client from the auto-generated client, and then throughout our test, we can instantiate this client, create our application, and then call our methods by simply doing app_client dot whatever our method name is and pass our parameters. We'll be going more in depth in how this actually works throughout the bootcamp series, but this goes to show how easy it is to take our contract, auto-generate this client, and import it and begin using it. It's just a couple of lines of code, which makes it really nice. Now to run these tests, I can go ahead and do an npm run test, and that's going to compile and generate the contract or generate the client for me again. And then it's going to run the test, which I've written here in Jest. And we can see here that our tests have passed. So if we take a look at our logs, what has happened is it logged all of our transaction IDs that we sent to our network. Now you might be asking, what network are we sending them to? These transactions happen really fast, and we know block times on our Algorand are roughly 3.3 seconds. So all of our testing was actually done on a local network that was instantiated by AlgoKit. So in the code space, every time you create a code space, it'll start your local network. If you need to manually start your local network, you can do an AlgoKit localnet status, and that'll give you all your information about your network that you need to know. Now, if for some reason your network stopped or you want to stop your network, let me show you this first. You can run AlgoKit localnet stop, and that'll use Docker to stop your local network. Sometimes it takes a second for the container to exit safely. And then we can also run AlgoKit localnet start to start up our network. And so whenever you run your tests, just make sure you have your local network running. Now, one other thing specifically for CodeSpace that you need to make sure you do is come on over to your ports tab and make sure you change your port visibility to public for 4001, 4002, and 8980. And when we eventually get to our front end, we'll also need to make that port public, but we're not running that yet, so there's no need to do that now. Opening your ports is something you only have to do in CodeSpaces, but pretty much the rest of this content in the bootcamp series is going to apply to both LocalNet, our local environment, and CodeSpaces. If you're interested in how to set up your local environment, which I recommend most developers do at some point in their development journey, you can check out the other video that's an introduction to this series using a local development environment before you get started with the rest of the content. So as I mentioned, this was an introduction to the bootcamp content. After viewing this video, you should be ready to use CodeSpaces to begin following along the bootcamp content and learn how we can leverage this directory structure, this project that we just learned about, to build your own project.
This is a video for people who want to set up their local environment when they're building with TEALScript, instead of using CodeSpace, which is a virtual environment on GitHub. All right, to set up your local environment so that you can build with TEALScript, you need to first install AlgoKit. So come to github.com/algorandfoundation/algokit-cli. The link will be in the description. Now come down here, and in the README, you'll see an install AlgoKit section. Click on that, and it will take you to the section that explains how to install AlgoKit. Now, first things first, you need to have Python 3.10 or higher. So go to python.org/downloads to download the latest Python version. You also need to have Git installed. We use Git to create and update projects using AlgoKit template. And then you also need to have Docker installed. Docker lets you run a containerized environment, and we use Docker to run a local Algorand blockchain on your computer. You'll be using that local blockchain to test your smart contract while building. To install Docker Desktop, come to docker.com/products/docker-desktop. And you can choose whatever machine you have right here. Now, AlgoKit can be installed in many different ways, depending on your local machine. But you can use pipx on any machine, so I'm going to walk through how to install with pipx. So click on pipx right here, and it will take you to this section. First, it's going to ensure that you have all these prerequisites installed. So we've installed Python 3.10 or higher, Git, and Docker. And if you haven't, you can click on these links to go to the installation page. But we haven't installed pipx yet, so let's click on pipx. And then down here, there's the instruction of how to install pipx, depending on your machine. I'm going to use pip to install pipx. So I'm going to copy this code, go to my terminal, paste it in, and install pipx. After you install it, make sure you copy this code, paste it in as well to add your pipx to your path. Now I've had pipx previously, so my pipx is already in the path, but you should see that your pipx has been added to the path. All right, let's go back to the AlgoKit GitHub. And the next step is to install AlgoKit using pipx by running this command. So I'm going to copy that, go to my terminal, paste that in, and that's going to install AlgoKit. And there you go. If you see something like this, this means you've successfully installed AlgoKit. And to just double check that it has been successfully installed, you can run algokit -- version. And you'll see something like this if you've successfully installed AlgoKit. Now here on step 3, it says to restart the terminal to ensure AlgoKit is available on the path. So let's just do that to make sure. Perfect. Now that AlgoKit is installed, let's bootstrap a TEALScript project using the TEALScript template. So to do that, you want to run AlgoKit init, and that's going to show you a list of project templates that you can choose from. You're going to choose TEALScript. It's going to ask for the name of the project, so I'll just say TEALScript demo. And then it's going to render the template. Then it's going to ask you if you want to run AlgoKit Bootstrap which is a command that's going to install all the dependencies that you need to build with TEALScript. So say yes to that. And once it's installed all the dependencies, it's going to ask if you want to initialize a Git repository, and I'll say yes to that as well. Now, once the initialization is completed, it's going to automatically open VS Code for you if you have it as your default editor. And if not, you can just open the project folder. Now, it will take you to this README file that has information about this template. But let's go to the folder, structure, and see what we have. Now, we have all of these configuration files down here, so you don't really have to worry about these. But you want to worry about this contracts folder. If you open that, it'll have an artifacts folder, clients folder, and a TEALScript-demo.algo.ts file. Now, this will depend on what you name your project. Right now, the artifacts folder and the clients folder are empty, but these will be populated when we compile and build the smart contract. So, let's take a quick look at the default TEALScript smart contract that comes with the template. Now, this is a simple calculator smart contract that has two private methods, getSum, getDifference, where getSum inputs two arguments, A and B, and returns a sum of that. And getDifference also takes in two numbers, A and B, and gets the difference of those two numbers. And then we have one external method called doMath, which takes in two numbers, A and B, and a string value called operation, which specifies what kind of operation you want to run. So if you take a quick look at this method, if the operation is sum, then it's going to call the private method getSum to get the sum of A and B. And if the operation is difference, then it's going to call the private getDifference method and get the difference of A and B. And it's going to return the result. So obviously, this is a default smart contract, so you can modify this code to build your project. Now let's try compiling and building this smart contract. To do that, first we need to run a local network on a computer. A local network is basically a private Algorand blockchain that runs on your computer that lets you test your smart contract in a safe and fast manner. So it's not connected to a public network. You don't need to pay real algos to test on here. It's just your own personal local blockchain for you to play around with. To do that, let's go to our terminal, and you need to run AlgoKit localnet start. Now, before we do this, make sure you have Docker desktop running in the background, because we're going to be using Docker to launch our local network. So make sure you have this on. Going back to the terminal, run this command, and that's going to start an AlgoKit localnet on your computer. Now, if you go back to our Docker desktop, you can see that AlgoKit sandbox has been created, and it should be running these three containers: AlgoKit Postgres, AlgoKit AlgoD, and AlgoKit Indexer. And if all three of them are showing these green icons and running properly, then you're good to go. Now, back to VS Code. Let's open up our terminal inside of VS Code, and let's compile this smart contract. Now, if you go back to the README file, there's the instruction of how to build your contract. So if you run npm run build, it will compile the contract to Teal, generate an ABI and an app spec. And it's also going to generate an AlgoKit TypeScript client. So let's try running that. npm run build. You should see this message, operation completed successfully. So let's open up our folder structure. And if we open the artifacts folder, now you can see all these files populated. Let's quickly go through what they are. TEALScript-demo.abi.json is an ABI file. The approval.teal file is the approval program in Teal code. This is the clear program in Teal. This is the extensive ABI that the front end can use. And we also have a source map of the smart contract. Now, if you open the clients folder, now we also have this TEALScript demo client.ts file. This is an auto-generated application client that you can use to interact with your smart contract. So for example, if you have a front end and you need to write code that calls the smart contract, you'll be calling the smart contract through this application client. Nice. So now let's test this default smart contract. The template also gives you this test folder, and inside of there, we have a test file. Now this test code is for the default calculator smart contract. And here, as you can see, we are importing in the application client as TEALScript demo client, and we are instantiating it over here as app client. Then coming down here, what we do is we use Algo SDK to generate accounts to play around with. We create an instance of the application client like this and set it to the app client variable. And we use the app client to create or deploy the application by doing appclient.create.create application. Now that the application is deployed on your local blockchain, we can test and call that smart contract. So here we're going to test the sum function. We have a const A set to 13, B set to 37. And we again use the application client to call the doMath method that we saw before. And we pass in these three arguments, A, B, and operation set to sum. And we expect the return value of that to be the sum of A and B over here. And again, we do the same thing for difference. So you can also modify this file to test your own smart contract. To actually run this file, again, open up your terminal and you can run npm run test. And if you do that, it will run the test file and show you how many tests you pass. Very good. So this is how you set up your local environment to build with TEALScript. Now, future videos done by Joe Polny for this TEALScript course, he will be using CodeSpace, which is a virtual coding environment, but you will still be able to follow along using your local environment. Now, there's one difference that you need to be aware of. In the video, Joe is going to talk about manually setting up ports for the CodeSpace. Now, because you're in the local environment, you do not need to do that. So whenever he's talking about manually opening ports for CodeSpace, you can just ignore that and do everything else the same.
Now that we've gone over the AlgoKit init command and how we can use a template to start our own project, and we've gone over the directory structure of the TEALScript template, so all these files, what these different directories do, now we can get started actually writing our own code. So we're just going to get started here in our contract. So again, this is the file that contains all the logic we're going to execute on chain. The template comes out of the box with some like calculator methods. So we're just going to delete those. We're not going to need those. And before we write our own methods, what I want to do is write some comments kind of explaining what we want to do. So basically, we want to define a proposal and make it easy for voters to see what the proposal is. Right? So a big idea of blockchain is transparency. And of course, if you're voting on something, you want to make sure that everyone's on the same page and you're all voting on the same thing. So what I'm going to get started with actually is a method called getProposal. And I'm going to return a string. And this string is going to describe our DAO's proposal. So what I'm basically going to say is return. And I'm going to return this is a proposal. Okay. So now when someone comes to our DAO, they're going to see that when they call getProposal, it's going to return a proposal. In our case, it's going to be this is a proposal. So if I do an npm run build here, and I take a look at our DAO.approval.teal artifact, we can see here that we have this getProposal string here, and that it makes it easy for voters to see what the proposal is, right? And has all the logic here that we need to do it. And the key thing here is that hard-coded is byte, this is a proposal. So if I when I go to my test now, I can come here. I'm going to delete the difference test, delete the logic here, and just call this get proposal. What I can now do is, because we import our DAO client, which, remember, it's a generated artifact from TEALScript, or excuse me, it's a generated artifact from AlgoKit that contains a typed client that we can use to call our contract methods. So what we're going to do, and we instantiate it up here under app client, so we can just simply do await app client dot get proposal, and all of our function calls take an object. In our case, we don't have any arguments, so our object's just going to be empty. And what I'm going to do is I'm going to say that we're going to save this as const proposal from method. Right, so we have this object, and what we need to do is write a test. Say we're going to expect proposal from method, return in this return. So if this was a void method, it would be undefined. So in fact, in our case, we'll have this question mark to signify, to tell TypeScript that we know this might be undefined, and that's okay. Obviously, in our test, we don't want it to be undefined, but that'll show in this test result. And we're expecting our value of to be, this is a proposal. Okay, so now if I do an npm run test, we can see here we create our app, and then our proposal that we got from our get proposal method is indeed, this is a proposal, right? Exactly what we expected. And so if we were to change this, this is another proposal, and we were to go ahead and run this again, you'll see that it now fails. Expected this is a proposal, but we got this is another proposal. So that works great. So we've defined a proposal and we made it easy for people to see what it is. But I want to take this one step further and kind of think about the long-term use case of a smart contract. So smart contracts, as I mentioned, they're written in Teal and deployed on the Algorand network. And so whenever someone wants to call this contract, basically what's happening is that this code is getting executed. And this has the proposal hard-coded in it. But what if I wanted to make two different DAOs using the same code? Well, right now that's technically impossible, because by changing what my proposal is hard-coded to, I fundamentally change the code of the contract. So what I want to do is make a way for the proposal to be set without directly hard-coding it in my contract. And to do that, we're going to use what's called global state. So on Algorand, any contract can save information to the chain. And there are multiple different ways you can save information. There's global storage, local storage, and box storage. But today we're just going to be focusing on global storage. So to get started with global storage, all we need to do is, if we come to the top of our contract here and we define a property in our class, and I'll just call it proposal. And this proposal value, I'm going to initialize it using this global state key function. Okay. And what that's basically saying is that our proposal is going to map to a key that holds a global state value. So when we say global state or global storage, what's actually happening under the hood is we're saving a key value pair in our contract. So on chain, we'll have various keys mapped to their respective values. Now, one thing we need to do, and this is one difference between TypeScript and TealScript, is that some methods require a type. So here what I'm going to do is I'm going to add a type argument, and I'm going to say that this global state key is going to be a string. In other words, proposal is going to hold a string for us. So now what I want to do is when I first create my contract, I want to set this global state. So I'm going to add a new method definition here, and I'm going to call it create application. Now this is a special method name. You can see here, so I'll define the signature, and then if we hover over it, you can see here that this method is called when creating the application. So if I come to create application void, and in here, I want to update the value of proposal, I'm going to simply say this dot proposal dot value equals this is a proposal. And then down here, I'm just going to simply update this to this dot proposal dot value. Okay, now it's important that we always remember this dot value. So if I were to just try to set this as this proposal, it's not going to work because this proposal itself is a global state value object. So to get to the underlying value in the global state key value pair, we have to call dot value. Okay, and so now that we've set our dot value, when we create the contract, so if I go ahead and build npm run build, when we create the contract, we're setting our proposal, and when we return it, we're going to be, returning it like here. Now the obvious thing is, I said one of the reasons why we want to update this proposal mechanism, and actually before I get to that, let me just, where was I just typing? npm run test. Let me just run the test to show you that this is still working. And give it a second. Okay, so our test ran, our get proposal function, and our creation is working as we expect. So let me explain kind of why we're using global state. Actually, I already explained that one of the reasons we're using it is that we want our contract to be able to change without the underlying code to change. So we didn't want to hard code a value, but right now you can tell we're still hard coding a value. But because we have this state object, you can maybe start to think of ways we can avoid hard coding this value. We now have our contract where we have a create method and we set some global state to our hard coded proposal, and then we can return that here in get proposal. So now what we want to do is we want to think about a way that we can eliminate the hard-coded proposal from our contract. Now, if you aren't already at this point, if you're in the TS beginner en repo, you can run the command git checkout v102, and then I'll bring you to this exact code space that we're at. So we're going to build off this, and let me write down in a comment what we're going to be doing. So we're going to modify this method so that we don't have a hard-coded proposal. Okay, now if you're familiar with development or specifically TypeScript, you can probably imagine how we're going to do this. Basically what we want to happen is we want our create application function to take an argument that the caller can use to specify their own proposal. So I'm going to make an argument called proposal. This is going to be a string type. And I'm going to go ahead and say that this proposal.value is now going to be equal to proposal. Okay, so if I now come over to my tests and I do an npm run build, what we'll see happen. Okay, so I'll pause the video for a quick second and adding in this recording in editing. I just wanted to point out that the latest version of the TEALScript template, or the latest version of TEALScript, no longer has that dot create dot bear method. So there's going to be kind of an awkward slice here where I just skip right to adding the argument to our create application method. So again, when I was recording this, TEALScript generated the .create.bear call. However, on your side now, instead of being .create.bear, by default, it should be already .create application. So ignore the fact that this says bear right now, and we're just going to jump ahead to where we add the argument to our create application. And now in here, we're going to pass in our argument. And you can see here, the type that's missing is proposal. So I'm going to define a argument proposal. And then I'm actually going to come up here into my test and define const proposal equals, this is a proposal. Okay. And now what we want to do is we're just going to change this actual test itself to be proposal. So we're expecting our proposal from the method. So the proposal that gets returned by this method here, we are expecting it to be equal to the proposal that we define here. So what's nice is, so if I go ahead and I do an npm run build, then npm run test, I keep creating that test automatically builds for me. So I do an npm run test, and I can see here that this test works. And in fact, just to be sure, I can add a console here just to show you. If I do a console.log, oops, and I log that return value, that's weird. I've never seen that before, so just cancel that. And I do an npm run test. You can see here that this is a proposal, is the proposal that typed, or that was tested against. And if I go ahead and update this, we can see here without modifying the contract source code at all, we're just changing the value in the test. We can now see that our proposal is updated. So the idea with state is it allows us to save values that are independent of what's hard-coded in the contract. And for those of you that are familiar with development, you know that having variables that aren't hard-coded is very useful and it makes code more repeatable. And that's exactly what we accomplished here. So just to kind of recap, this was going to be a pretty short video, but we've basically modified our method here. So our create application method, we've modified it so that we pass in an argument, and that argument is then passed into our global state. So now our contract has some state that it's saving, and we're telling it to save a key called proposal, and that proposal key is going to point to the actual proposal we pass in. In our case, it's going to be, this is a proposal. So the next step that we want to do is we've kind of got our initial scaffolding for a proposal. We can now build on top of this. And as you can imagine, the whole point of a DAO is so that users can vote. So in the next video, we'll be showing you how to implement voting functionality. We have our contract here. We have our create application method where we set a proposal and store it in global state. And then when we call get proposal, we return the value saved in our global state. So now the next thing we want to do is we want to update this contract so that people can actually vote. And so, actually, before we continue, let me just say to get caught up, if you are not at this point in the code, if you're in the TS beginner repo, you just do a git, check out v103. Okay, so what we want to do is we're going to save votes in our global state. So I'm going to say votes total, so the total number of votes. This is going to be a global state key. This time we're going to be saving a number. And what we want to do is I'm just going to create a new method called vote. This is going to be void. And we're going to simply do this dot votes total dot value. Never forget your dot values. Equals this dot votes total dot value list 1. Now you might be asking why we can't just do this. This is not yet supported in TEALScript. Hopefully by the time you're watching this video, it has been added in. But for now, we got to explicitly write out this votes total dot value. Okay, so what we expect to happen is every time we call vote, the amount of votes will increase. So what I'm going to do is I'm also going to come down here and I'm going to make a method get votes. This is going to return a number and oops. And in here, I'm just going to simply return this dot votes total dot value. So very similar pattern to what we did with our proposal, except of course this time we're doing a number and we have a function to explicitly increase it. And I should mention that by default, if you don't set a value on your global state, it's just going to default to 0. So the first time we call vote, this is simply going to be 0. So let's go ahead first, actually make sure that we build, and then we're going to go ahead and update our vote function, or update our test, I should say. So the first thing I want to do is let's go ahead and make a test, and we're going to call this vote and get votes. And we're going to define our async test. What we're going to do is we're going to await client.vote. And then we're going to say const votes after is going to be equal to await dot, oops, excuse me, not dot, await app client dot get votes. Okay, and then here we write our test much like before. We expect votes after dot return dot value of not to be 1. Okay, so if I go ahead, do an npm run test, and this is a good thing to mention, I forgot about. So in our contract, we're returning a number. And by default, in the AVM, every number is an unsigned 64-bit integer. So the problem is in JavaScript, we can't work with numbers that big, right? The default number type can't get that big. So I guess we can't use that notation. So we need to specify that the number being returned is a big int. So we expect this getVotes function to return a value, and we expect it to be a big int type because it represents an unsigned 64-bit integer, which cannot be represented through a JavaScript number. And that's why we can see here expected 1 received 1n. So if we go ahead and run that again, that 1n just means it was a big int. So we go ahead, run that again. And we can now see that we have indeed passed our test. Okay, so we've implemented a vote functionality, but what we want is not only for people to say, yes, I support this proposal, but allow people to be actively against a proposal. So right now, if someone wants to vote in favor of the proposal, they simply call this vote function, and that increments the counter, and all is good. However, what we want to happen is we want our vote function to now take in an argument for whether we support it or not. And what we're going to do is, so let me write in the comments what we want to do. So change this method to support to allow the user to say if they are in favor or not. And then down here, change this method to return total votes and votes in favor. Okay, so you can pause this video if you want and think about how you might implement this. I'll give you a second to do that, but we're just going to continue right on here in this video, kind of showing the solution, how we do that. So if you want to take some time to figure out, how you might approach this yourself, pause the video, or for the boot camp, we'll pause it for you and we can, talk about ways to do this. Otherwise, if you just want to see the solution right away, just keep watching. So here, what we'll do, and I assume if you don't want to see the solution yet, you pause by now. So let's get into the actual code. So what we want to do is we want to come to our vote method, and we're going to change this and add in a single argument called in favor, and we're going to set that to be a Boolean. And what we're going to do is we're also going to come over to our properties up here. We're going to define votes in favor, and that's going to be global state key, and that's also going to be a number. Okay. So basically what we want to happen is we want to increase our votes total regardless, and then have an if condition. If in favor, this dot votes in favor dot value equals this dot votes in favor dot value plus 1. Okay, so now our vote function, it'll increment not only the votes total, but the votes in favor. So if I do an npm run build here, we'll see that our app client.vote method now expects in favor. I'm going to change in favor. I'll change it to true. And let's go ahead and actually run these tests, make sure everything works, and then we'll update our getVotes function to return an array of both the in favor and the total votes. Okay. So now what we want to do is we want to update this function to return an array. So I'm going to come over down to getVotes, and I'm going to simply have it return number. Okay. And so down here, we're going to return this dot votes in favor dot value. Always remember our dot values, and this dot votes total dot value. And at this point, we should do a npm run build. In our tests, we should now see, or actually, the test framework isn't aware of our types. So what we actually are going to do is let's just run this test as is right now and see what happens. So the only thing we've changed between now and the last test is this method now returns an array. And we can see we expected 1n, but we got 1n, 1n. So let's do a couple things here. So first, we're going to change this oops, to be begin button. Oh, sorry, get rid of the end. And I think we also, let me check my notes. Yes, we also need to change this to be dot to equal. Okay, so now if we come down here and run it again, we should see that we've now passed. Now, one other thing we're going to want to do is if we come into our same test that we just ran, we want to test the opposite case. So we're going to await app client.vote in favor, let's set it to false. And we're going to basically do the same thing. And we're going to expect that this first number, so our votes in favor is going to stay 1, but our votes total is going to increase. So let's go ahead and run that. Okay, and so now we can see that our tests are passed. So our vote functionality worked with our in favor is true, and worked with our in favor set to false. So now at this point, what we've demonstrated is that we can expand our usage of global state to contain information about our votes, and not only the total votes, but also our votes in favor. Now, the obvious problem with this, however, is that we don't have any way of ensuring that, a given user can't vote multiple times, right? That person can always come in and change their vote. Anyone, whether they've been involved with the DAO before, can vote. And the biggest issue is that you are exposing yourself to Sybil attacks. So in the blockchain, anyone can create an address and participate in the network. So if one person really liked a proposal or really didn't like a proposal, they could just make thousands of addresses and vote in, however they want to. And so what we want to do is think about mechanisms in which we could deploy to prevent that from happening. Okay, so now we have a contract where not only do we have a mechanism for setting our proposal, but we also have a way to vote either in favor or against said proposal. So now the next step, as I mentioned, is to find a way to help prevent against Sybil attacks where one person can create multiple wallets and easily vote, swing the vote in their favor. So what we are going to do is we're going to use a token to represent eligibility to vote in the DAO. And in particular, what we're going to do is we're going to have the DAO mint its own token. So what I'm going to do is I'm going to create a method called bootstrap. And it's going to return an asset. So basically what's going to happen, someone calls the bootstrap method, the contract will mint a token, and then return that token that it minted. Now, in order to create a token on Algorand, it's pretty simple. We're just going to say const registered ASA. And in order to create a token on Algorand, all we have to do is send an asset config transaction to create a new token. So on other chains, you have to create a whole new contract to represent a token. On Algorand, tokens are a primitive feature of the blockchain. They're called Algorand standard assets. And we can use these Algorand standard assets, or ASAs, to represent both fungible tokens or non-fungible tokens. In our case, we're going to be creating a fungible token. So I'm going to call send asset creation. And in this send asset creation, it's expecting a couple of fields. I'm going to say the config asset total is going to be 1,000. In other words, there's going to be a total minted supply of 1,000 tokens. And because we're going to use this to determine whether someone can vote or not, this basically means the max amount of votes in our DAO is going to be 1,000, and only 1,000 people can participate in our DAO at any given time. So what we're going to do now is we are going to set another field saying config asset freeze. And what this is basically going to do is prevent the user. So once they register with a DAO, they can't send their DAO token to someone else. So by setting config asset freeze to a specific address, the address that you give it has the ability to freeze tokens in people's wallets. Now, of course, this is a completely optional field in asset creation. However, we want to use it to make sure that people aren't, selling their DAO membership after the fact. So what this send asset creation is going to do, it's going to mint 1,000 tokens, and it's going to allow this application, so this app address is the address of this application, it's going to allow the logic in this application to freeze and unfreeze assets in any given account of the DAO token, of course, or as we call it, the registered ASA. And then what we're going to do is we're simply going to return registered ASA. Now, one thing I also want to do is I'm going to go ahead and set a new property here. I'm going to say registered ASA. That's going to be a global state key. And here we're going to say it's an asset. Okay. So now at this point, we have this bootstrap method that we can call in order to mint an asset. So let's go ahead and try to do that. So what I'm going to do is come over to our test here. And let me make sure I put this in the right place. Yeah, so I'm going to come below get proposal. I'm going to write a new test. It's going to be called, bootstrap. And this is going to be an async method. And what we basically want to happen is we're going to await app client. I forgot to build. So first let me do an npm run build. Okay, let's just try calling the bootstrap outright and see what happens. So if I do an npm run test, we're going to build again. You'll see it while we're developing this, I'm just going to skip this test. So what happened here? Oh, this was incorrect. Okay, so let me, good thing I didn't skip the test right away. Okay, so let me go ahead and run this again. So now what we should see, and by the way, by the time this video is posted, I'll fix this, so you won't have to fix that. Anyways, so let's go into the actual problem I want to focus on here. And we can see here that we encountered an error when we tried to send our inner transaction. Now, unfortunately, just for whatever reason, cuts off our error message. So I'm just going to write some code. You don't have to do this. I'm just doing this to kind of demonstrate what's actually happening here. And we're going to do console.warn e, and then we'll throw e again. Okay, so if I come down here again, let's take a look and see why our bootstrap method is failing. Okay, so come up here. I got this beautiful error message, all to say the fee is too small. Okay, so why is it saying that, right? We've sent all these other method calls just fine. So the reason it's saying fee too small is because here in our DAO, we send an asset creation transaction, and that transaction, its fees need to get paid. You can see here, if we wanted to, we could specify the fee, but that would pay from the contract account. And we don't want that to happen. So the fee is 0, right? By default, if you don't set a fee, it's going to be 0. So what does this mean for our client? Well, it means that when we call it client side, we need to double our fee, right? So by default, every Algorand fee, so default fee per transaction is 0.001 algo or 1000 micro algo. So Bootstrap sends one inner transaction, so 2 transactions total. Thus, our fee needs to be 2000 micro algo. Okay, so how do we update our fee? So to call our method, right, I mentioned our first argument is the arguments to the onChain method. And our second argument is going to be parameters on the client side. So we're going to say our send params, and we're going to set our fee to AlgoKit.microalgos 2000. Okay. So when we send this transaction, the account sending the transaction, instead of just paying 1000, it's going to pay 2000 microalgo. So let's go ahead. Now that we've dealt with the inner transaction fee, let's build it again and see what happens. Or test it again, I should say. And we still ran into a failure. So what's going on here? Now we can see that we got this error, balance 0 below min 2000. And this brings us to a very important concept in Algorand called minimum balance requirement. So by default, every account on the network needs to have at least 0.1 algo or 100,000 micro algo. And so that's just the default balance that you need to have in order to be included in the ledger. If your account has 0 algo in it, then the ledger isn't keeping track of it, which makes sense, right? Like, why take up space in the ledger if you don't have anything? So by default, if we want an account to show up in the ledger, we need 0.1 algo or 100,000 micro algo. However, anytime we create an asset that also increases the minimum balance requirement by an additional 0.1 algo. So anytime we do something on chain that increases the amount of space we're taking up on chain, so when we create an asset that adds something to the Algorand database, thus making it bigger, so we need to pay for that space somehow. And the way we pay for that space is through the minimum balance requirement. So what this error message is saying is that our contract is trying to hold one asset, but it has 0 algo. So it's not even in the ledger, and it has less than 200,000. And we need 200,000 because it needs the 100,000 to be in the ledger, and then an additional 100,000 to hold an asset. Now this can be a little bit confusing at first, so in the description of this video and in the bootcamp, we'll give you links to the developer docs, the developer portal, where we kind of explain minimum balance requirement in a bit more depth. But the key here is, in order for our contract to hold a asset, the asset that it creates, it needs to have 200,000 micro algo. So to do that, what we're going to do is we're going to call await app client dot app client dot fund app account. And we're just going to simply pass in AlgoKit dot micro algos 200,000. Okay, so let's go ahead and run this again. If all goes according to plan, we should now have a passing test. Okay, great. And one thing we do want to do is we want to set, so we're going to just say const bootstrap result, and we're going to set we're going to have a new variable. So I'm going to come up here and say let registered ASA be a big int, right? Because it's a UN64, so it's going to be a big int. And actually, let me get rid of this try catch thing here. And then our registered ASA is going to equal bootstrap result dot return dot value. Why is this complaining? Oh, max line length. So I think I should be able to do it like this. Okay. So let me match exactly how I have it in my notes, just so when we push, it's not a surprise. Okay. Oh, and we're going to change this to an exclamation point. Okay. And for those that aren't familiar with JavaScript, or TypeScript, I should say. So when we have a question mark here, so actually let me get rid of this question mark. If we don't have a question mark, it's going to tell us that it's possibly undefined. A question mark tells TypeScript that it's okay if this is undefined. An exclamation point says we know that this is not undefined, right? And we know if our bootstrap method works, then this will not be undefined. Okay, so, and then let's just go ahead and we can do a console log here just to show that this works. Give it a minute. Okay, and we can now see that this registered ASA does indeed work. So now what we want to do, oh, I forgot to show you the console log. We can see here it logs. So an asset ID on Algorand is just a UN64. So the asset that we created was ID 1109. Okay, so we've created our bootstrap method, but now what we want to do is we want to do two things. First, what we want to do is we want to make sure that this method is only callable once. So if I come in here, what I basically want to happen is I want to assert that, okay, I want to assert the negative of this registered ASA ID dot, oh, no, it's not registered ASA ID, it's just registered ASA exist. So to give some context here, so this assert, what the assert command does, it's very similar to like a Python assert if you're familiar with Python. But basically what we're doing is saying, if this condition is true, then continue on. But if it's false, then throw an error. Okay? So basically what we're saying is only allow this method to be callable once. Right? So we only want this method to be called once. And when we do call it, oh, and I just realized I also forgot to set this. Okay, so once we do call it, we're going to set a registered ASA value, and that will prevent it from being called again. So what this function is going to do, it's going to check to see, has this function already been called? And it'll do that by seeing if registered ASA has already been set. And if so, it's just going to fail for us. Now, The other thing I want to do is I want to protect this method to make it only callable by the application creator. Now, in the context of what we have right now, this isn't particularly super important because we already have protections to make sure it's only called once. So technically anyone can call it and that would be fine. But for demonstration purposes, I want to show how we can verify that the person calling this contract is the app creator. And this is a very common pattern. Generally, you either check if it's the contract creator or in your contract, you have some state defining who the admin is. In our case, we just want to verify, that the person calling this is the person that created the app. So to do that, I'm going to use this verify transaction function. And what this function does is it allows us to verify specific fields in a transaction. So if I call it verify transaction, I want to verify a field in this transaction. And then I specify what field I want to verify. So I want to verify the sender is equal to this app creator. Okay, so what's basically going to happen is if I try to call this method and I am not the app creator, then it will simply fail. So to demonstrate how that works, what I'm going to do is I'm going to come back over to our tests, and I'm going to make a new argument here. I'm going to say let sender equal, actually no, that's not going to be equal. It's just going to be an algo SDK dot account. And then here in my before all, I'm going to generate a new account. So previously, this whole time, everything we've sent has been from this one account, test account. But it's common in your testing that you want to involve multiple accounts. So the easiest way to do that is if we get a new account from our KMD. So first, actually, before I do that, let me quickly show you. So if we do an AlgoKit localnet, we can see here we have a couple of commands. And the command we want to run is AlgoKit localnet. I thought there was a goal command. Goal account list. Maybe it's just not listed for some reason. Oh, okay. I guess we have to do AlgoKit localnet console. And then if we do a goal account list, we can see here we have multiple accounts here in our local net. So these are all accounts stored in KMD. And what we basically want to do is create a new account that we store in KMD. So to do this, we're going to say sender. It's going to be equal to await, get, or create KMD wallet account. The name is going to be TEALScript DAO sender, and we're going to call fund with, and that's going to be algokit.algos10. Oops. So we're going to give this, we're going to create an account and name it TEALScript DAO sender, and then it's going to fund it with 10 algos. Right? So if I call algo D, this is also going to be KMD. Okay. So up here, we've just added KMD to get it from the context here. And then we are setting our sender. So the first time we call this, it's going to create an account called TEALScript DAO sender, fund with 10 algos. And then the second time we call it, it's just going to get that same account because it saved the name. So what we want to test now is we're going to try to call this bootstrap method. So I'm actually going to copy this and And first, let's test the negative. Okay, so what we're basically going to do is we're going to, in our call, we're going to set the sender to this new account that we created, right? So we create the contract with our test account, and then we're going to try to call the bootstrap method with our sender account. I'm going to go ahead and skip this for now. Right. We can delete this. You don't have to delete it, but I'm just going to delete it to save some algos. So if I exit out of my AlgoKit console and I do a npm run test, right, we expect this bootstrap negative to fail. Right, and we can see here we're getting the creator of this app. Is it equal to the address that we passed in or the address that we called the application with? And it's not, so it's throwing an error. And that's exactly what this verify transaction function is doing. Okay, so now let me just go ahead and update this. We're going to await, expect AlgoKit client.bootstrap dot rejects dot to throw. Okay, so now we're saying because we're calling it with an account other than the test account we created the app with, we expect this to fail. Okay, so again, to kind of recap, we created a new account in the network, and then we've gone ahead and we added a test that tries to call the bootstrap method from that account, and we expect it to fail because we verified that the transaction sender is this app creator, which is not true because we might have manually changed the account. And now if we come ahead and we retest our bootstrap call here, we should now see that our bootstrap method is passing. Oh, and we skipped. Let me just unskip this so we can show all the tests running. Or all the tests passing, I should say. Okay. Now, the one thing that we're missing here is ideally we have a function to return our registered ASA. So we're going to pretty much just copy this, return a number, no, actually return an asset, and we're going to return this dot registered ASA dot value, get registered ASA, and then we're going to come down to our get proposal method. And after we bootstrapped, I'm just going to copy that and call get registered ASA. And then it's going to complain because it hasn't built yet. So I'm going to do an npm run test, which should get rid of that error. And then we should see, oh, I just realized I need to fix this. And then we now should see oops. And we expect this to be registered ASA. Give it a second. The more tests we add, the longer it takes to run. If you're familiar with the JavaScript ecosystem and you're comfortable using Bun, I personally recommend using Bun. In my experience, test against a local network are like 3 times faster than Node.js, but we're just going to stick with Node.js to keep it simple. But you can see here that we've now, passed all of our tests. Okay, so at this point, what we've done is we've minted our DAO token in the Bootstrap method, and we verified that only the creator can call Bootstrap and that we actually are bootstrapping successfully. And then we can get our registered ASA. Okay, so now the next step is going to be actually using this ASA. And again, if you're new to Algorand, there's going to be some concepts that you might find difficult to navigate exploring on yourself. However, the next step, what we're basically going to do is we're going to have a register method that uses inner transactions to send and freeze the ASA in the caller's account. Okay, so now we've created our Bootstrap method and we created an ASA to signify that someone is eligible to vote, but we haven't yet actually implemented the functionality that ensures that a person has the ASA before they vote. So what we're going to do now is we're going to create a method that people can call to register with the DAO and get their ASA. So the first thing I want to do is I'm going to come over right above my vote function here, and I need a method, register method, that gives the person ASA and then freezes it. So remember, in our ASA creation, we set the freeze field, which allows this app to freeze the asset in a given account. And we want to do this so that that person doesn't vote and then give the ASA to someone else, and then they can vote using the same ASA. So what we're going to do is transfer it and then freeze it. Now, this part is pretty simple. So we're going to write a method called register, and this is going to simply be a void return. And the first thing we want to do is we want to make sure that the person calling this method doesn't or does hold the asset. Or excuse me, no, doesn't hold the asset, right? So we only want people to have one asset of this registered ASA token. We don't want someone to have 2 because we want to have 1,000 members total. So we want to make sure that this person doesn't yet have one. So what I'm going to do is I'm going to assert this transaction sender, and then there's a method called asset balance, and I'm going to pass in this registered ASA ID dot value. Okay, so what this is going to do, it's going to return the balance that this account is holding of this asset. I want to make sure it's 0. Okay, so I'm basically saying make sure that this method can only be called once by any given account. Now, once I can be assured they don't already have the asset, I'm going to do a send asset transfer. And I'm going to pass in an object here. And in this object, I'm first going to define the X for asset. In this case, that is going to be this registered ASA ID value. And then I'm going to define the asset receiver. And so that's going to be this transaction.sender. And then finally, I'm going to define the asset amount equal to 1. So now that we have that, the next thing we want to do is actually freeze it. I'm going to do send asset freeze. Now I'm going to specify the freeze asset, and that's going to be this registered ASA ID value, the freeze asset account, and that is going to be this transaction sender. So the freeze asset account is the account that we're going to be freezing. And then freeze asset frozen is going to be true. So we're basically saying send a freeze transaction that freezes the asset of this registered ASA ID value in this account. So we transfer it to the transaction sender and then freeze it in their account so they can no longer transfer it. And that's the totality of this method, or at least all we're going to write for now. So let's head on over to our test and talk about how we can test this. So if we come down, let me see, check my notes, see where I'm putting this. Okay, so if we come down here, I'm going to make a method called test register. And of course, we're going to have our async function here for our actual test logic. And what I'm going to do is first, actually, let me just try calling register right off the bat. So I'm going to do await. Yeah, I know this is going to fail. Spoiler alert. So I'm going to try and await app client. Oh, I forgot to build. Let me just build so I can get my types. App client dot register dot app client dot register. And now I'm going to catch my error, console log my error, and then I'm going to throw my error. Okay. So let's see what happens when we just try to run this test as is. So we should see here, and just give this type of the future. So here we can see our error. So we got asset holding get is where the actual error was in our teal code, but we can come up here to actually read the error. So it says logic. Oh, that's right. So what's happening is that we're actually filling on this line, right? So what's happening is we try to get the balance of this account, but this account doesn't actually hold the ASA. Yeah. So, or actually that's not the problem yet. Let me comment this out before we get ahead of ourselves, actually. So I'm going to comment that out for now, and I'm going to run this again, and we'll encounter a first error, and then we'll come back to this line of code here. It's just a little bit easier to talk about this way. So pretend we didn't write that line of code yet. And now we can see here a little bit more clear of an error that unavailable asset. And 1203 is the asset ID, and that's presumably our registered ASA ID, because that's the only asset we're actually using here. And so what this basically means is that the AVM didn't have this asset loaded in memory ready to go. So on Algorand and in the AVM, anytime you interact with some piece of the ledger, some piece of the underlying database behind Algorand, you need to predefine what you're going to be reading or writing. Now, this applies to assets, but it also applies to accounts and applications. But of course, in this case, we're going to be going over assets. And so what this basically means is an asset on Algorand at the end of the day is just a table in an SQL-like database. And it's the same thing for an account. An account is just a table in an SQL-like database. So what we basically need to do is make those tables available for the AVM. Now, because our account is the one sending it, right? This transaction sender is the account that's sending this transaction. We don't need to explicitly make it available because the AVM knows that something is going to happen with this account. It's going to send this transaction. However, the AVM doesn't know that we're going to be accessing this table. We're going to be accessing the registered ASA, right? So we need a way to tell the AVM that we're going to be accessing this registered ASA. Now, under the hood, there's a specific field in a transaction that you can fill in order to tell the AVM. However, in a high-level language like TEALScript, all I need to do to tell the AVM that we're going to be working with a specific asset is just pass it as an argument. So here, I'm going to say registered ASA is going to be an asset. And that's all I need to do. You'll notice here, ESLint is going to complain about we're not using this variable And that's actually okay. We don't actually need to use this variable. All we need to do is pass it as a parameter just so the AVM knows you're going to be accessing it. And it's very important that we actually aren't using this value, because if I, for example, try to do something like this and just use the value passed in, what would happen is the user could decide which ASA this transaction is going to try to send. Now, in this case, the code would just outright fail because this app only holds the registered ASA. But in other cases, it's a security concern. So make sure that you're always reading, if you have like an asset stored in your global state, that you're always reading from your global state rather than your arguments, because the user can set your arguments to whatever. So basically, to recap, we pass in an argument of an asset to tell the AVM that we're going to be accessing this asset, but we don't necessarily need to use it in our method because we can just read the asset from our state. So let's go ahead and try to run this test again. Actually, it's going to fail because I need to now pass my registered ASA. Okay, so let me go run that again. So I updated my register function call here to pass in the registered ASA. And now if we try to run it again, let's see what happens. So we're going to run into another error. And this is the same error that we ran into before. Fee too small. So we're just going to come over here, update our send params, and set our fee AlgoKit micro algos 2000. So again, same thing we did up here. Actually, we need to set it to 3000. So earlier we only did one inner transaction. This time we're doing two. So we need to pay 1000 micro algo for our app call, 1000 micro algo for our transfer, and 1000 micro algo for our freeze. Okay, so now that's done. Let's go ahead and run that. And now we can see yet another error. Let's see what it is this time. We're seeing receiver error must opt in. So this is an important feature of Algorand. So earlier I mentioned that anytime you have an asset in your account minimum balance requirement, the amount locked in your account that pays for storage, needs to increase, because when you add an asset to an account, you're increasing the size of that account's table in the underlying database, and we need to pay for that. So the way we do that is we simply send an asset transfer of that asset from ourselves to ourselves of 0 amount. So let me show you what I mean by this. So what we're going to do is we're going to create a transaction. So I'm going to call it registered ASA opt-in transaction. And I'm going to use the algo SDK .make asset transfer transactions with suggested params from object. Now, I know that is a mouthful, but basically what this is saying is we're going to use the SDK to form a transaction, and we want to pass in suggested parameters, and I'll talk about what that means in just a second. And we're going to use an object to instantiate it rather than just passing in arguments. Okay, so our from is going to be our sender. R2 is going to be our sender. And our amount is going to be 0. And then our asset index is going to be registered ASA. Now you'll notice that's going to complain about the type. Here, the SDK expects a number, but AlgoKit returns a big int. So we're, oops. What the heck did I just do? Oh, I exited full screen. Okay, sorry about that. Okay, I just completely lost. Okay, give me 1 second to open that back up. I don't know what I just hit, but I hit something that closed it up. Okay, so sorry about that. So we need to cast our big int to a number here. So we just do a number big int. And now the last thing we need to pass in is our suggested parameters. So suggested parameters are basically information about the network that we need to pass to our transaction. So on Algorand, when you send a transaction, you need to define your fee, which round it's going to start being valid on, which round it's going to end being valid on, what is the genesis hash of the network that you're submitting it to, and a couple other fields. And so these are a lot of fields that most of the time we can just ask the network to tell us what we should use. And so in our case, we're going to use AlgoKit dot get transaction params, and we're going to pass in algod. So if we take a look at the method signature here, we need to pass in suggested params. So we have params we already want to set, but we don't want to do that in this case. So we're just going to set that to undefined and then pass in our algod. And so what this is going to do, AlgoKit is going to talk to the network we're connected to through our algod client here and ask it, what's the current round? How long should my transaction fee be valid for? What's the fee that I should pay? All that sort of stuff. And the reason why we use a method here rather than manually defining it is twofold. A, it just makes our life a little bit easier. We have to, define less fields. But B, it also makes it so that we can use the same line of code regardless of which network we're connected to. So if we're connected to our local network like we are right now, it'll get the transaction params for a local network. If we're connected to testnet, it'll get the params for testnet. And if we're connected to mainnet, it'll get the params for mainnet. So very nice helper function there that's baked in to this SDK with params function. Okay, so now that we've formed our transaction, so we've formed basically the metadata of our transaction, but now we actually need to send it to the network. And to do that, we're going to do AlgoKit send transaction. And this transaction is going to come from the sender. And the transaction that we're actually going to be sending is going to be a registered ASA opt-in transaction. Now, and we need to define, of course, our algod. So tell AlgoKit how we're connecting to the network. Okay, great. So now what we've done is we've told the network by sending a transaction from ourselves to ourselves of zero amount of the asset, we've basically told the network, hey, I want to be able to receive this asset, make some space in the database for me. And what will happen is we'll now add space in the database for this asset entry in this account, and it will also take away 0.1 microalgo, or excuse me, it will add 0.1 microalgo to this account's minimum balance requirement. So one other thing I forgot to do is we're also going to say a register is coming from our sender. So just for a reminder, we have our test account that is going to actually be creating the app. And then we created our sender from our KMD. And we're going to be using a separate account to actually register. So now if we go ahead and run this test, what we should hopefully see, probably should skip even more tests too, so it's a little bit quicker, but that's okay. Coming up on the end here anyways. Now we can see that we have our registered method passing. So to recap, what we needed to do is in our DAO.algo, we've sent the asset, then froze it, and then this person, before they can call that register method, they need to opt in by sending a zero asset transfer from themselves to themselves. Now, one thing we also want to do in our test here is, let me get rid of these try catch blocks, is we want to verify that the asset is actually frozen. So what we're going to do is we're going to form a transaction to transfer the asset. So if I do registered ASA transfer transaction, we're going to do a very similar thing. So algo SDK make asset transfer transaction with suggested parameters from object. I'm going to do from sender to sender amount, just keep it at 1, asset index is going to be number, register why is complaining. Obviously missing something here. Oh, that was just slow. Okay, that's fine. Okay, and then finally my suggested params. Wait, AlgoKit get, what is it? Get transaction params, undefined, everybody. And no, what is this? Registered ASA. Okay, so what we're going to try to do is send a registered ASA to the network. Actually, I shouldn't have gotten rid of my try catch yet. So let's try to send that and see what happens. We're going to wait. I'm just going to copy this line, make our lives easier, and then, okay. So we're going to try that, and then if it doesn't work, we'll throw our error in, log the full error. While that's running, let me skip some of the tests that we can skip. So I think skip that, skip that, skip that. Okay. So you can see here, the asset is frozen. So this transfer didn't work because our asset's frozen. So what we're basically going to do is expect this to reject to throw, right? And let's put this on a new line here and get rid of the try catch block. Okay. So now if we go ahead, is this still too long? Yeah. Yes, I'm still going to complain about that. Okay, so if we go ahead and run this again, so basically what we're saying is we expect this to fail because it should be frozen. Oh, I probably skipped a test that I shouldn't have. Let me remove these skips. Tried to save some time and I clearly messed something up, so let's try that again. Okay, there we go. So we can now see that our test is passing, which means this indeed did fail as we expect. Okay, so, and then one last thing is we're just going to add back this assert to make sure that someone doesn't register more than once. If I come back down here, remove everything, we can now do a test again. And everything should work. And then I forgot one last thing. So while those tests are running, one thing we want to do in our vote function is we want to assert that the person calling it does indeed have the asset. So we're going to assert this transaction.sender dot asset balance of our this registered ASA ID dot value is going to be equal to 1. Okay, and let me double check that we're not missing anything. Okay, I think we're good. So now let's just quickly add a test before we let me just make sure I'm putting this in the right place. So before we register, what I'm going to do is I'm going to try to vote. And this is a negative test, so it should fail because we don't yet have the asset. All right, so we expecting app client dot vote in favor, and this can be whatever. I'll just say true, pass in my and one other thing is we also need to pass in registered ASA asset for the same exact reason that we added it before. We need to tell the AVM that we're accessing it and pass in our registered ASA. And then we expect this rejects to throw. Okay, so if we go ahead, run this again, our type should update here, so this will be valid. Yep. And I think in my, so two things. Forgot my async here, and then also have to update my other calls now with my registered ASA. Okay, so let's run that again. I think that covers everything. Yeah. Okay, so now all of our tests have passed, and this added test basically just makes sure that we cannot vote when we don't have the registered ASA. Now, there's a couple problems here that are still left. So the first one is that when a user registers, they get the ASA, but then they're stuck with it. There's no way for them, to undo their registration. So you'll want to think of ways that maybe we could do that. And then we'll also want to think of kind of longer term, right? Like, how do we prevent a single user from voting multiple times? So you might notice that this, if we go back here, this vote function, there's nothing preventing somebody from voting multiple times. And so basically, as long as you have the ASA, you can vote however many times you want, right? So we want to think about ways that we could prevent that from happening. And in general, again, just preventing, Sybil attacks and the kind of attacks that a single bad entity could employ. Okay, so now that we've finished our contract, at least the beginner portion of it, what we're going to do is we're going to connect it to a front end using React. So the first step for doing that is we're going to create a folder specifically for all of our TEALScript development files. So basically, I'm going to move all of these files into its own directory. So I'm just going to create a new directory here. I'm going to call it TEALScript. And I'm going to go ahead and copy everything other than the dev containers into this TEALScript directory. Okay, so at this point, you should now have a TEALScript folder in your top level directory, and then the exact contents of the repo we had before underneath TEALScript. Now, the next thing we're going to do is we are going to, in this root directory, so in tsBeginnerEn, we're going to run the command AlgoKit init. And we are going to select the React template. So before we selected TEALScript to develop our contract, and now we're going to select React to deploy our front end. So we're going to hit React, and I'm going to call it front end. It's going to start the template copy. And I'm just going to go ahead and select all of the default options here. Now, of course, as you're building your own app, you can pick and choose which ones you want. But for the bootcamp, if you want to follow along, definitely make sure you choose all the default. In particular, make sure you choose Tailwind in Daisy UI. So that's going to go ahead and get bootstrapped for us. So give it a minute to set up that directory. Actually, I'm going to cancel this as it is now. And just so it doesn't open up a new tab, because it normally does. So now at this point, we have our TEALScript directory, which has our contract, and our front end directory, which has our front end. And what we want to do is we're going to run AlgoKit bootstrap all. Now, the nice thing about Bootstrap is it will go ahead and bootstrap all of my dependencies all the way downstream. So it's going to bootstrap all the dependencies on front end and all the dependencies in TEALScript. And this is one of the reasons why using Bootstrap is preferred over using just npm install, because it'll automatically resolve subdirectories and install the dependencies. Now, the other thing here is you can see, because I canceled it earlier, it's saying .env already exists. But the other thing Bootstrap does is it initializes a .env file. And that's not included by default before running Bootstrap because we don't want that to be checked into GitHub. Okay, so now what we've done is we've bootstrapped our repositories. We can see here that we've bootstrapped 2 different npm packages, one for the TEALScript and one for frontend. And now if we go to cd frontend, so in our front end directory, we will run npm run dev. What's going to happen is it's going to open up a front end just like this. And so now what we need to do is if you go to wallet connection and connect to your KMD, you'll notice that it didn't work. And so if we take a look at our console here, we can see that we failed to connect to KMD, right? Error connection refused. And the reason that's happening is because it's trying to connect to KMD on my local host, but I want to connect to KMD in my CodeSpace. So the first thing we got to do is we got to come to front end and then open up our .env. In this frontend.env file is where it contains all the information about how we connect to the network. So by default, it assumes you're connecting to a local network. And it also has configurations for testnet and mainnet. So what we want to do is we basically want to change this. Instead of connecting to a local host, we want to change it to connect to our GitHub CodeSpace. So if we come over here to ports, what we want to do is come on down to each port, AlgoD, KMD, and indexer, and copy the URL. So I'm going to right click on AlgoD, copy local address, and then paste that in. And then I'm also going to change the port to 443 because we're connecting to HTTPS. So before this was AlgoD port 4001, now we have the URL with 4001. We're going to do the same thing for we're going to do the same thing for our Gitpod, for our indexer. Well, that was the wrong URL. Do the same thing, just got a little confused there. Do the same thing for our indexer, change this to 443, and then we're going to come down to KMD and do the same thing. Copy local address, replace local host, and replace the port with 443. So we should now see AlgoD server is our code space with a 4001, our indexer is our code space with 8980, and our KMD is our code space with 4002, and all of our ports are going to be 443 because we're always going to use HTTPS. So now if we come back, we can see because we modified our env, Vite has restarted the server. So if I come over back to my front end here, I'm going to reload just to clear the console a bit, and I go ahead and connect. Oh, it's going to throw an error probably because I don't have my ports open yet. I forgot to do this, so I'm going to come back here, go back to the ports menu. I'm going to change all my port visibilities to public. So AlgoD to public, KMD to public, and indexer to public. Now, if you're still using the same code space you've been using throughout the bootcamp and following along, then you shouldn't need to do this again. However, I just initialized a new code space, which is why I needed to do it again. So now I'm going to come back over to the front end Let's try it one more time. Wallet connect, local wallet. And now we can see that we've connected to this local wallet, this AXR wallet. And so if I come back here, I can see that my front end server is running, and this is the server that it's running. So at this point, you should have your front end directory and your TEALScript directory. And what we want to do is come down to front end source app.tsx. This is kind of where the main logic for our front end is contained. So if we go ahead, we're going to do an npm run dev. I'm going to open this up. And we can see here, we have our template here. What I'm going to do, I'm just going to open up a split view and make this a little bit smaller. So now we can see here that we have our front end on the left here, and we can start modifying it. So first thing I'm going to do is I'm going to say, welcome to the DAO. And I'm going to say, this is the front end for the Algorand Bootcamp DAO. Okay, so we can simply see that just making those simple changes itself updates automatically here. And now what I want to do is if I come and take a look, we can see here we have this getting started button, wallet connect button, and transaction demo. I'm going to delete this getting started link here. Okay, get rid of that. And then what I'm going to do is I'm going to delete this transaction demo button. Okay, so now we just have a divider and then our wallet connection button, and then we can start adding our own buttons afterwards. And I'm also going to delete this transact modal because we're not using it. And then if we go up here, we can see that there's some stuff that we're no longer using. You don't have to delete the stuff we're not using. I'm using a demo modal. Okay, I think that takes care of everything. So at this point, all we have here is a button that allows us to connect our wallet. And so if we want to take a look at how this actually works, underneath the hood, we're using, let me get rid of this too. Underneath the hood, we're using this use wallet library provided by Transaction Labs. It's an open source library that allows you to easily connect to any wallet in the ecosystem. Because we're connected to our local net, the only option we have here is our local net wallet. But at the very end, I'll be showing you how we can switch to testnet and then connect to other networks and wallets. But for now, we're just going to stay on our local network. So when we do local net wallet, we're just going to connect right away to this local address here. And this is just an account on our local net that is pre-funded. Okay, so we've seen here, we've made some very basic changes. We've changed the text here and we've removed the buttons we don't need. But now we can actually get into adding the buttons we do want. So the first thing I want to do is I want to have a, actually let me get rid of this divider as well. Actually, I'm just going to move it. Where is it? Divider. I'm just going to move this down below here. So we're going to have a wallet connection up top and then a divider in our DAO specific buttons down here. So basically what I did is I just removed all the buttons we don't need and removed the related code so we can start integrating our own buttons. Now the question is, how do we integrate our own buttons? Now, of course, you could make your own components that interact with our app manually. However, if we come, I'm going to open up a new terminal. I'm going to cd into the TEALScript directory. And we can see here that there is this artifacts components directory. Oops, and I realized I forgot to remove that, so I'm just going to rm contracts artifacts, components. You don't need to do this. I'm just doing this to demonstrate how it works. So we can see that there's this artifacts, components directory. Wait, why did that not work? There we go. Just did an auto update for some reason. Okay. So we come back to TEALScript, artifacts, components. We can see here that this components directory is empty. However, if I run this command, npm run generate components. Oh, and I forgot to do an AlgoKit bootstrap, so let me do that. AlgoKit bootstrap all. So that'll install my dependencies for me. And if I do npm run generate components, it's going to generate all of these components. Why is this not auto update? That's very strange. So it's going to generate all of these components here for me. So we can see here for each method in our contract, it auto-generated a unique component. So here what we're going to do is we're going to take this DAO create application, because the first button we want to implement is the button to actually, create our application. So we're going to right click on this, we're going to copy, and then we're going to come into our source components and paste. So what we've done is we ran npm run generate components. That generated this DAO create application component here in our TEALScript directory. And then we copied it to our source components directory here in our front end. Okay, so if we go ahead and let me minimize this while we're not using it. If we go ahead and take a look at our DAO create application component, we can see here that we have an example usage. So I'm going to go ahead, I'm going to copy this, and I'm going to put it right here below this divider. Okay. For some reason, my ESLint isn't working either. So what I'm going to do is I'm going to pause this video and refresh my code space, because VS Code seems to be a bit slow, and then I'll come back in 1 second. Okay, sorry about that. I just needed to create my VS Code settings JSON to enable ESLint on save and format on save. So got that out of the way now. Anyways, and you don't need to do that. It's just my personal preference. I like having my code formatted on save, and you can alternatively just copy this VS Code directory out to the main branch as well, or into the main directory. Okay, getting back on track here. So what we can see here is if we came DAO create application, we just copied this example, pasted it here. Actually, let me split view this. We can see here that we're getting an error occurred. And what's saying is DAO create application is not defined. If we say here in our IDE, we can also see we have a bunch of stuff undefined. So let's go ahead and start defining this stuff that's not here. So the first thing I need to do is import DAO create application from the component. So this is the component we copied over. We're going to go ahead and import that. Okay, and now the next thing that's not defined is our typed client. So what we're expecting here in our typed client is an instantiation of our client that we already have generated here in our clients. So I'm just going to go ahead, right click, copy. If I go to TEALScript, contracts, clients, DAO client, and then copy, then come back to our front end. I'm going to paste that. Why is paste? There we go. Paste that into my contracts directory here. And now what I need to do is instantiate it. So I'm going to come up here and I'm going to say, oh, actually first I need to import it. So I'm going to do import think this is called DAO client from contracts DAO client. Okay, and I'm gonna come down here and I'm just gonna say const type client equals new DAO client. And I'm going to pass in an object here, and I'm going to say resolve by ID, and my ID is going to be 0. Okay, so this is very similar to what we did. If we come back, take a look at our TEALScript tests, we can see here we're doing pretty much the same thing. So we're importing our DAO client, resolving by ID, setting it to 0, but this time around we're not explicitly sending a sender. And that's because we need to get the sender dynamically each time we use our DAO client. So we're not going to be setting the sender right away. And now the other thing we need to pass in, so if we take a look at the error here, it's expecting an AlgoD argument. So I'm going to create another variable called AlgoD client. I'm going to say this is AlgoKit dot get. Oh, I don't have it's imported either. So let me do import star as AlgoKit from AlgoKit utils, and then come back down here, get algo client, and I'm going to pass in my server is going to be from my AlgoD config server. My port, test it, AlgoD config.port, and then my token is AlgoD config.token. And this AlgoD config, it's getting the configuration for our AlgoD client, so how we connect to the network from our environment variables. And now what we can do is we can just simply pass AlgoD client here. Okay. So again, to recap, we've imported our DAO create application. We've imported our generated TypeScript client. We've imported AlgoKit to create an AlgoD client and a typed client. And now we can pass that to our DAO create application. The last thing is here, we don't have our proposal variable defined. So I'm just going to hard code this for now to this is a proposal. If I come over here and I refresh, what we can now see is if I go to wallet connection and I connect to a wallet, actually, and one other thing, I'm going to change this to create DAO. And I click create DAO. What we should see happen is if we open up our console, we'll see here that we've sent a transaction that created an application. So what we've done up to this point is we've slightly modified our React template to have our own button. And that button was rendered by this component that we just copy and pasted from this generated file. And we can see here that we have successfully added our first interaction between our front end and our DAO contract. So at this point, of course, we have our, if we come back to our app.tsx, we have our proposal hard-coded. And what we want to do is we want to avoid having that hard-coded value. So in the next session, we'll be talking about how we can provide a way for the end user to provide their own proposal. Okay, so now what we have here is our front end with our create DAO button that simply creates the DAO with this hard-coded proposal. But of course, we want our function to take an argument, and we want that argument to be provided by the user rather than taking in a hard-coded value. So let's talk about how we can modify this DAO create application component to take in a user-defined proposal rather than a hard-coded proposal. So the first thing, I'm going to take a step back and kind of explain what exactly this code is doing for those not familiar with React. So what's happening here is this first active address this is coming from use wallet, which is a library that allows us to connect to a wallet. And by default, we're just connecting to localnet. However, once we switch to testnet or mainnet, it will also allow us to connect to a bunch of other wallets in the Algorand ecosystem. And what this is basically saying is if there's an active address, then we want to render this component. So if we have our wallet connected, render the component, otherwise don't. And now the actual component we're rendering is defined here in DAO create application. So if we come here, we can see DAO create application is the name of our component, and its argument are what we call props or properties. So in these props, one of the things I've defined is a proposal that can be passed in. So here we're passing in the property proposal as this is a proposal, and that's what's getting used to create the application on chain. So now what I want to do is, actually let me show how this works. So I'm going to go ahead, pop open my console, make this a little bit bigger, and I'm going to make sure, yeah, all is connected. I'm going to hit create DAO. And we can now see here that we have created this application in this transaction. So I'm going to come back to here. I'm going to run AlgoKit localnet explore to connect to my local blockchain explorer. And if I paste in this transaction ID, I can see this is an app call. And what ended up happening, if I come down in here and take a look at my global state, I can see here, this is the value. So if I just come to a base64 decode, take a look at what that is. This is a proposal. Okay, perfect. So in other words, what we had hard-coded here is what was passed to create DAO when we ultimately called it here. So now what we want to do is I no longer want to pass a value from this component. So I'm going to go ahead and delete that. I'm going to delete this. And now you're probably wondering, where is the proposal coming from, if not from our app.tsx? And what we're going to do is we're just going to define a input element directly in this component itself. So we're going to come down to our render here, or our return, and you can see here it returns a single button, and that's this create DAO button. What I'm going to do is I'm going to change this to return a div that contains both a button and a input. I'm going to pause the video for 1 second. I'll be right back. Okay, sorry about that. Just had to fix my settings here so I could get auto format on save back. Again, just come into your settings JSON and make sure you have format on save true and fix ESLint true into your settings if you like auto format. I personally always use it, so that's what I'm using here. Okay, so what I'm going to do is I am going to have a div that's going to have an input and a button. So this input is going to be where we eventually type our proposal. So I'm going to say input type is going to be text, and our class name, because we're using Daisy UI, I'm going to say it's input and input bordered, and I'm going to give it a margin of 2. Okay. So now we can see by having this component render not only our button, but our input, we have this input box and now our create DAO button. So what we want to do is basically set it so whatever is typed here is what's passed in to our proposal. Our method as our proposal argument. Okay, so what I want to do is I want to create a new state that saves our proposal. So I'm going to say proposal, set proposal, and that's going to be use state string. Oh, excuse me. That's going to be an empty string by default. So for those that aren't familiar with React, what we're basically doing is we're creating a variable called proposal, and we're going to allow this variable to be updated through this set proposal function. And whenever we call set proposal, any component that depends on the proposal variable is going to be updated, right? So in other words, this proposal value is always going to be the value that we most recently called set proposal with. So we now are passing in a proposal, but by default, it's just going to be an empty string. So the question is, how do we update the value of proposal when we type here? And what we're going to do is we're going to come to our input. So in here, in our input element, we're going to say on change, and we're going to define a function. It's going to take an event. I'm just going to call it E. And I'm going to say, I'm going to do two things. Well, first, I'm just going to, actually, before I do anything, let me just show you. I do console.log e.current target dot value. Anytime this field changes, so whether I'm typing letters, I'm cutting letters, or I'm pasting letters, it's going to trigger this onChange function, and we can get the value of our current element by calling the event.currentTarget.value. Okay, so instead of logging it, what we actually want to do is we're going to call set proposal. So now whatever we type in here, React is going to call set proposal and pass in the value we've typed in. So our proposal value that we pass here is going to match what we typed in. So I'm going to say, this is my custom proposal. Actually, I'll probably need to refresh. I'm going to say, this is my custom proposal. I'm going to go ahead and create the DAO. And we can now copy over this transaction ID, come back to DApp flow, paste in the address. We can see our global state delta, it's no longer. And if we decode this base 64, we can see this is my custom proposal. Excuse me, went to the wrong place. So now if we come take a look back, what we've basically done is we've added this use state call to define our proposal rather than passing it in through our props. Pass in the proposal use state variable as an argument to our function call, and then added a text input element. And anytime that text input element changes, we call set proposal, passing in the current value that is populating this text field. Now, one other thing we want to do while we're here modifying our create application is we're going to also bootstrap our contract. So if you remember, we have one create method and then a bootstrap method that mints our DAO token. So what I'm going to do is I'm going to call wait props.typedClient, and I'm going to call the bootstrap method. Now, if we remember, this is why it's useful to write tests. If we come back to our TEALScript test here, we can see, where's bootstrap? We can see that we needed to fund the account and we needed to call bootstrap with a double fee. So I'm going to go ahead and do the same thing. So let me first update this. So we're going to do send params. We're going to set our fee, AlgoKit. Oops. AlgoKit. I forgot to import it. That's why. Import star as AlgoKit from AlgoKit utils. It's going to be AlgoKit.microalgos, say 2000. Let me just put this on its own line here so it's a little bit easier to read. Okay, And so we're going to call Bootstrap, but before we do that, because it's creating an asset, we also need to do props type client dot app client dot fund app account. And here we're going to pass in our sender and set our amount equal to AlgoKit dot microalgos 200,000. Again, let me bring this onto its own line so it's easy to read. And I forgot one thing I also need to do here is define the sender as well. And add my column. Okay, so in addition to adding the input, what we've also done is we've modified it. So we're going to fund the app and then bootstrap it and do with this all once we click create DAO. So this is my custom proposal. Oh, it's not gonna work because we already created it. So let me refresh. This is another proposal. I'm gonna create the DAO. We'll have one transaction to actually create it. We'll have another transaction to fund it. And then we'll have one last transaction to actually bootstrap it. And now at this point, if we go ahead and we copy the transaction ID, let's actually take a look at the application. We can now see that we have our proposal, but we also have a registered ASA ID. If we take a look at that, we can see this is our registration asset that we've minted 1,000 of. So just as a reminder, what our bootstrap method does, let's take a look at that. We can see here that when we call bootstrap, we create an asset which has a supply of 1,000. And that is exactly what we saw just now on our local explorer. So what we've done in this video is we've modified our DAO create application component to take in a text input for its proposal by deleting the proposal property, creating a use state value, passing it to our function, and then setting proposal based on the value of our input text field here. And then we've also gone ahead and funded it and bootstrapped our app so it can go ahead and mint the ASA. Okay, so now we have our custom text input where we can create our DAO. However, the problem is that this front end is still going to show this button even after it's been created. If we try to click it again, it's going to run into an error. Attempt to create app, which has already been created. So what I want to do is a couple of things. The main thing is I want to make sure that this isn't rendered once we create the app. But as an extra bonus, we're going to add a text input that'll allow us to define an app ID. And the reason we're doing that is if someone comes to this page and they want to connect to a DAO that's already been created, they can just type in the app ID. So the first thing I'm going to do is I'm going to start with the UI and then add functionality. So I'm going to come to my app.tsx here, and underneath this divider, I'm going to add a new H1, and I'm going to say DAO app ID. Okay. I'm going to just add some basic Daisy UI CSS to this. I'm going to say this is going to be bold and give it a margin of 2. Okay. So under DAO app ID, what I'm going to do is I'm going to create a new input. Its type is going to be number. Oh, what just happened there? Its type is going to be number. And I'm going to, how is DAO? Huh, that's weird. It just auto-deleted my import. Let me add that again. Okay, so formatting just got a little bit messed up. Okay, so we're going to have our number input here. And we're going to give it, of course, input and input bordered here. So we're going to show our app ID in here. And what we're going to do is we're now going to say how we define our app ID. So I'm going to come up here. Where are we? And I am going to say const app ID, set app ID. This is going to be use state number, and its default value is going to be 0. Okay, and so now if I come back down here to my input, let me put these on new line so it's a little bit easier. So I come back down to my input. The first thing I want to do, I'm going to say our value is going to be app ID. Okay, so now it'll be 0 by default because that's our use state default value. And I'm going to define on change. This is going to, again, take a function, and we're going to say set app ID. This is going to be current target value as number, and in case the user deletes the number altogether, we're just going to add this or 0, right? So whenever we change this, our app ID under the hood is going to be updated to this value here. And all I'm going to do now, so I'm just going to add another divider here. So I'll copy that div class name divider. So now we have our app ID here and our button down here. And so now what we actually want to do is we want to, when we create our DAO application, we want to update our app ID. So I'm going to come over here into our props. I'm going to define a prop called set app ID. And that is just going to be a void function that takes in a app ID number void. Okay, and this is going to be our set app ID from app.tsx. And so what we're going to do now is in our component, after we've gone ahead and done the create and bootstrap, I'm going to say const app ID, and we're going to destructure the value of await props type client app client dot get app reference. Okay, so what this function does is it basically gets the app ID of our application. And so once we got the app ID in that variable, we're just going to call set props set app ID, and that's going to be app ID. Okay, and we want to make sure we cast this as a number here. Okay, so now, of course, because we've added our prop to our component here, it's going to complain that we don't have it here. So I'm going to go set app ID, set app ID. So what we've done is we've created a set app ID function from use state, and then we're passing it down into this child component, into our DAO create application. So now when we create our application, what should happen is our app ID is updated. And I should mention, one other thing we want to do is change this app ID up here. So whenever we change it, it changes our DAO client. So if I go ahead and I do blah, 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 I hit create DAO, I might need to refresh. We'll see if this works. It's going to go ahead and start creating the DAO. And now we can see we've updated our DAO app ID to 10,011. And that's the app ID of our DAO that we just created. And so now the last thing we need to do is, because this is already created, we want to delete this create DAO function, or excuse me, this create DAO button. So I'm going to add another condition, and whoa, app ID equals 0 and. Okay, so now we can see once our app has been created, there's an app ID here. That button goes away. But if it's back to 0, we can then go ahead and create another application. So without refreshing, we've created another application. So before it was 10.11, now it's 10.15. So now our app.tsx will always know what the current app ID is and render components depending on if there's an app rendered or not. Okay, so at this point, we've modified our function. So now, and the cool thing is too, is if I come in and type 10.11, later on, I can just directly interact with the votes or, vote functions and get the proposal from that. But we're not there yet. But just want to lay the framework for why we're making this a changeable value. Because again, we made our DAO not have a hard-coded proposal, so multiple people can use the same code to deploy their own version of the DAO. And that's exactly why we want people to be able to define their own app ID. And so we've done that. We first come into app.tsx. We've added a new input that we've tied to our app ID state. Every time it changes, we update our state. And every time we create our application, we now call set app ID. So set app ID, and importantly, I should mention, we've modified our typed client to instantialize a DAO client based on the app ID that it's currently in the React state. So now our client will always be pointing to whatever app is in here. And if we just create it, it's going to update the app ID automatically. Okay, so at this point, we've gotten our create function nailed down. This is exactly the functionality we want when it comes to creating. However, that's not the only thing our DAO does. We don't want to just create it. We actually want to interact with it. And the first step to interacting with it is being able to see what the proposal is, right? We don't want people to vote if they don't know what the proposal is. Now, you could just tell them to go look at a blockchain explorer, but here on our front end, we want to do it all for them. And so in our next video, we're going to talk about how we can read the state to display the proposal to the end user. Now, the important thing is here in our tests, so if we come back to our TEALScript function, or that's not the right thing, I want to open up our contract. There's this get proposal function, but we don't actually want to send an on-chain transaction every time the front end reloads. So I'm going to show you how we can load the state of a contract without calling one of its methods. So that'll be in the next video. And if you want to think about what the UI looks like, you can start working on that. And then in the next video, I'll show you both the UI and the solution for actually reading state. So I'll see you then. All right, at this point, we now have our app. We can see here that we have our DAO app ID. It starts off as 0, but if I go ahead and create my DAO, what should happen is it's going to create the DAO with the proposal we type in. And then this is going to go away because we don't want to create it twice, or we can't create it twice. And what we ideally want to happen is our register and our vote functions pop up here. But before we do that, there's something very important we need to do to our front end, and that is to display our proposal. So to do this, I'm going to get started with writing the UI, how I want it to look, and then we'll talk about how we actually populate the UI based on chain state. So the first thing I'm going to do is actually, let me show you where I'm at. So in my app TSX, in the return value here, I'm coming down right below the DAO app ID and copying over this H1. And I'm just going to simply name this header to votes. And I am going to, or excuse me, we're not doing votes yet, we're doing proposal. And so underneath the proposal, what I'm going to do is I'm going to have a text area. And we're going to say class name, it's going to be text area bordered, and give it a margin 2. Oh, there we go. And what I'm going to do is basically show that if I make a proposal, and let's say this is a proposal. This is what I want the user to see before they actually vote, right? So I want them to know what the proposal is before they register and vote. So that's all the changes we're making to the actual UI. The rest of the changes are going to be focused on how do we actually get this value from our app. So what I want to do is I basically want a way to, so if I come up here, right above my, actually, let me come over here. So first what I'm going to do, I'm going to create a proposal, set proposal, and I'm going to say use state. This is going to be a string, and by default, it's just going to be empty. And then what I'm going to do is I'm going to come down here to my new text area and say value equals proposal. Okay, so now we've set this, we've hard-coded this value to be equal to our value of our proposal state. And so what we're going to do is we're going to now write a function that updates proposal. So we're using proposal, now we got to use set proposal. And to use set proposal, basically what I want to happen is every time, write out a comment, every time the app ID changes, get the corresponding proposal. Okay, so I'm going to write a function to do this. I'm going to say const get proposal. This is going to be an async function. And what I'm going to do is I'm going to say const state equals await typed client dot get global state. So this is going to go to our application and get all of the global state values that are defined in our application. And then from here, I'm going to call set proposal. I'm going to set it to state dot proposal. And for now, I'm just going to exclamation point that as string, right? And this exclamation point is basically saying, I know for a fact that this state is defined. And as we'll see in a second, that this isn't actually true and we'll have to handle this error, but we'll come back to that momentarily. So now what I want to do is every time the app ID changes, so let's get the connection. Every time the app ID changes, I want to call get proposal. So the question is, how do we do this in React? And we do it by what's called a effect. So if I write this, use effect, and this probably isn't imported yet. Oh, it is automatically imported for me. Great. And what I'm going to do is you pass in an anonymous function, and I'm going to say get proposal. All right. And at this point, what should happen is every time this effect is ran, it calls get proposal. But now the question is, how do we actually get this effect to run? We come down here, add a second argument, and for this argument, we're going to pass in app ID. And so now, anytime app ID changes, this use effect is going to get ran. To show that, I'm just going to do console.log here and show you how that works. So let me open up my console. Make this a little bit bigger, make this a little bit smaller. And so now every time my app ID changes, you'll see here. But you'll notice that we're throwing an error here, right? So we're trying to get the state of app ID 1, app ID 12, app ID 1, 2, 3, and none of these apps actually exist, so it's going to throw an error. So what I want to do is I'm going to wrap this in a try catch block. So I'm going to try this. And if that throws an error, I'm going to catch the error. I'm going to log it, but I'm going to set the proposal to, invalid app ID. So basically, if this fails for whatever reason, so it could fail for two reasons. A, the app just doesn't exist itself, or B, the app exists, but it doesn't have a proposal set, in which case it's not a DAO, and we're going to write out invalid app ID. So now, if I go ahead, I create my DAO. Nope, I forgot to type a proposal. But we'll see our proposal. Actually, let me show that again. So this is my proposal. Go ahead and create my DAO. We can see here for DAO app ID 1160, this is my proposal. If we change this to anything else, it just says invalid app ID. Now we don't want this to happen on app ID 0 because that means it hasn't been created yet. So I'm just going to add a condition here. I'm going to say if app ID is equal to 0, I'm going to set the proposal to the app ID must be set manually or via DAO creation before loading the proposal. Okay. And so now if I go ahead, oh, and I forgot to return. Also need my return. So now when it's 0, it'll tell me this message. When it's a valid app, it'll show the proposal. And when it's an invalid app, it'll say invalid app ID. Okay, so now at this point, we've shown how we can use useEffect to monitor app ID changes and then render the proposal based on the app ID that we have loaded. So in the next video, we're going to talk about how we can actually use this to start to conditionally render our components down here so we can show the register and our vote functionality. Because of course, our DAO doesn't do much if our users have no way of voting. Our DAO proposal mechanism, where if we change our app ID, it'll either be invalid or it'll tell us what our proposal is. And now what we want to do is we want to render our register and our vote buttons. So to do that, we're going to use our register and vote components generated by our TEALScript repo. So if we come to our TEALScript directory and then go to artifacts, components, and I'm going to click on DAO register and DAO vote.tsx. I'm going to copy and come back to our front end under source components. I'm going to go ahead and paste. So now we have DAO create application, but we also have register and vote here. And so now what I'm going to do is I'm going to head to my app.tsx and I'm going to first start with my UI as usual. And I'm going to copy this same logic that we did for create application, except I'm going to change it to when the app ID is not 0, because we only want our register and our vote functions to show when the app ID is not 0. So now what I'm going to do is I'm going to come back to my components. I'm going to get the register example and paste it in here. And then I'm going to copy in this and do the exact same thing for my vote example. So copy the example. And here we go. So first thing I need to do to get this working is import DAO vote and import DAO register. And once we have those two imported, we'll still have some errors down here. We'll see that our registered ASA isn't set and our in favor isn't set. So what I'm going to do is I'm going to create some state for our registered ASA. And much like in the contract, registered ASA is going to be the asset ID. Where's my use state? Register ASA is going to be my asset ID for the DAO token, right? So this is the token, this is the ID of the token that a person must hold in order to vote. So I'm going to set its default value to 0. And then for vote, what I'm going to do is I'm going to, actually first, let me show you, I change this to true. And then I go to a known app. We now have call register and call vote. I'm going to change this register to vote. And then I'm going to modify what I render here. So underneath, or so surrounding my DAO vote component, I'm going to put it in a div. And then I'm going to copy and paste the same component and just set it to false. And so now, actually, let me swap this what I want. This to be false and this to be true. Other than if I do vote against, vote in favor. So now on the left is vote against, on the right is vote in favor. And I know that because our first DAO vote component has in favor false, and our second DAO vote component has in favor true. Okay, now if I go ahead and try to run this, it's going to fail. And it's going to tell me, where is it? Unavailable asset. So the first thing we need to do is get the proper value for our registered ASA. So right now in our use state, we just have it hard coded to 0. So I'm going to go ahead and write some logic for updating that. In particular, what I want to do is I'm going to come down to my get proposal function, and I'm going to rename it to get state. And then I'm also going to use this as an opportunity, to set registered ASA. It's going to be state registered ASA ID as number. Now this time around, we are going to allow registered ASA ID, or say registered ASA ID might be undefined, and it would be undefined in the case that this is a valid DAO, but it hasn't yet been bootstrapped, in which event, if this is undefined, then we're just going to set our registered ASA ID to 0. And we'll handle that later in our code and how we render the components. But for now, we know if there's a registered ASA ID, so if there's a bootstrapped DAO, then we'll get the number of the ID. And because this is in our get state, this is going to run every time our app ID changes. So now if I come here and I update this and I call register to vote, what's going to happen now is we're going to run into an assert failure. And if we take a look back at our contract, so without even tracking down the exact line, if we come to our contract and take a look at our register method, the assert that's failing here is checking if the user holds the token. So what we need to do is modify our DAO register call to do an opt-in first. Now the nice thing is that we've already written our tests. So if we come to TEALScript test DAO test, and we go to our register function, you'll see that we already have this defined. So I'm just going to copy this code and I'm going to paste it in here. Now there's a couple imports we're missing, so I'm going to import algo SDK, and then I'm going to import AlgoKit. And so if I come back down here, I change this to props. This will already be a number in this case. Oh, just kidding. No, it won't be. And so what we're going to do is, we can see the one thing that's still undefined is our algod. So I'm going to go ahead, come up to our props, and define a new property called algod client. And this is going to be an algo SDK algod v2. And so now I'm going to pass in props Algorand client. And I'm going to do the same thing down here. And if we take a look at our test, we note that we sent the send params with a fee of micro algo 3000. So I'm going to copy that and paste it in here. Again, this is the benefit of writing our tests before we write our front end. We already know exactly how we need to call our register function. So we don't need to debug it in our front end. We've already done the debugging in our tests when we initially wrote them. So we know we need to do the opt-in and we need to send the transaction with a fee of 3000 micro algo. And now to get this working, we're just going to come back down to our DAO register function and define Algorand client is equal to Algorand client. And so now if I call register again, I'll see we did one transaction for the opt-in, one for the application. Actually, let me take a look at this. So I'm going to do AlgoKit localnet explore, and let's take a look at this transaction. We can see that this is an app call and it has 2 inner transactions. And if we scroll down, when we call our register, remember it transfers the asset and then freezes the asset. So we have 2 inner transactions. The first one was a transfer, so it transferred the token 1163 to our caller account. So this AXR account, if we come back to here and we look at our wallet connection, AXR is the account we're connected to. So it transferred the token to that account and then it froze. So this ST2 is our contract account and then the contract froze it. So it sent 2 inner transactions, thus why we needed to set the fee. Oh, I thought it showed the fee somewhere. Oh, here it is. Why we need to set the fee to 3000 micro algo. Okay, so our register function is working. Now let's get our vote functionality working. So if we actually go ahead and vote, it'll work just fine. So let me head back to that flow. We take a look at this app again. We can now see that our votes have showed up. But what we want to do is we want to update our UI. So we basically want to have the votes show here so the user knows that they actually did something. So I'm going to come up underneath where we have a proposal. I'm going to copy and paste this header again. I'm going to rename it to votes. And then I'm simply going to have a paragraph where I display votes total divided by votes in favor. Or I should say over votes in favor. Now these we haven't defined yet. So let's go ahead and we're going to say const votes total, set votes total. That's going to be use state number 0 and then const, actually let me just copy this, votes in favor, set votes in favor. Okay, so we're going to have 2 different states, votes total and votes in favor. So we see votes 0, 0, and we need to update that, and we're going to do that in our getState function. So I'm going to simply call set votes in favor 0, or excuse me, state dot votes in favor dot as number. Okay, and we're going to do the same thing here, set votes total to state dot votes total as number or 0. Okay, so the only other thing, so if we go ahead, let me actually show you this working now. So we'll see when we come to DAO 1160, it'll show, oh, I think, oh yes, I want to show votes in favor over votes total. Makes a little bit more sense. So we have 2 votes total, one of them are in favor. If I would go ahead and vote against, we actually won't see it updated. So this brings us to a good point. So when I click vote against, I'm going to click it a second time, we should be seeing 1 out of 4, but it's still saying 1 out of 2. And now if I change this app ID, it'll update to 1 out of 4. Now we have to ask ourselves, why is this happening? This is happening because the only time we update our votes is in this getState function. And right now we are not tying it to our vote functions at all. So what I'm going to do is I want to pass in this setState function to our votes component. That way we can call it after we vote. So I add the props here. I come into the props here in DAO vote, and I say set state, and this is going to be a void method. And then after we call the method, I'm going to simply do await props dot set state. So after we click register, it will I forgot I need to make this async. Oh no, that's not how you define it. You define it like this. Sorry, I forgot how TypeScript worked for a second there. Okay. So now we do await props dot set state. Oh. This should be called getState. My bad. GetState. And we're going to come up here to our vote, getState. And we're going to await props on getState. Okay. So now, if we come to 1160 again, and I'm going to vote in favor, we'll now see both our votes updated, and we'll vote against to show this working. And we'll see the votes total update again, vote in favor. And then if we leave, actually this is something we still need to implement. So if we leave, what's going to happen is it's still going to show the votes from the last app ID, right? It's not going to reset itself. So we need to do that ourselves. So what I'm going to do is I'm going to implement a function called reset state. And this is going to be a very simple function. I just set registered ASA to 0, set votes in favor to 0, and set votes in total to 0. So set all of our state to 0. And here I'm going to reset state. And then down here, I'm going to reset state. Okay, so now if I come to 1160, we'll see 3 out of 7. If I come to 0, we'll see 0 out of 0, right? So that's the exact functionality that we expect. Okay, so now at this point, we are able to create our DAO. And then we'll see our register function, or our register button, and our vote button. However, you notice if we try to vote before we register, it's going to throw an error. So in the next video, we're going to talk about how we fix this. And the key is that we want to check if the user is holding the asset. And depending on if they're holding the asset or not, we're going to render either the register or the vote in favor. So I'll see you then. Okay, so now we have our DAO where we can put in our app ID, we get the proposal, we can see the votes, and we can place our votes. But now what we want to do is we want to make it so that we only see the register if we need to register, and we only see the votes if we need to vote. And remember, the key to determining whether you can vote or not is this registered ASA value. So basically what we need to, or is this registered ASA asset. So what we need to do is check the state to see if the connected account is holding the registered ASA. So I'm going to create a new function called, or a new piece of state called registered, set registered. And this is going to be a Boolean that simply determines whether someone is already registered for the DAO or not. And then I'm going to come back down here and I'm going to add yet another condition to my register function. And I'm going to say, and not registered. And then I'm going to come down to my vote segment and say, and registered. Right? So now if we come back here, because we have registered hard-coded to false, it's only going to show our call register button. And if I change this to true, and I come back, it's only going to show our vote. But we want to do this programmatically, of course. So I'm going to change this back to false. And what I want to do is basically, once I get my state, I'm going to save a variable just called ASA. And do it like that. So now we have this variable that we can reuse called ASA that we're going to set as the registered ASA. But what I also want to try to do is determine if the user is holding ASA. So to do this, I'm going to get asset info from the chain. So I'm going to say const asset info, and this is going to be equal to the value of await AlgoD client. Oh, why did that just autofill? Account asset information. Let me put this on a new line. And we're going to pass in here our active address, so the user that's currently connected, and our ASA. Now, whenever we interact with AlgoD, you'll notice that this is not an async function yet. What we need to do is call .do on it. And this will actually send the request to the network. So we're forming the request to get account asset information for active address for our ASA. And what we're basically going to do is we're going to set registered. Actually, what I'm going to do first, so let me just console log what this actually looks like. So if we come here, come to 1160, and we take a look at what the response looks like, we have our top level object, asset holding, and amount. So we want to basically set registered to asset info, asset holding dot amount, and is that equal to 1 or not? So if the user has one asset of our ASA, then it's going to be true. Otherwise, it's going to be false. Now, the one thing we need to do is there might be a case where we have an uninitialized DAO. So we're also going to throw this in a try catch block. Oops, messed up my copy. We're going to try to get the ASA info. And if not, we'll just set registered to false. Okay. And this is going to be false actually under two conditions. So this will throw a 404 if the app doesn't exist or the set registered ASA doesn't exist and it's 0, or if our active address doesn't hold the ASA yet. So in either of those conditions, it will fail. In either of those cases, we want to set registered to false. Now, the other thing we need to do is we need to, actually, I think we've done that already. Yeah, so now if we come over here and we go to 1160, we'll see that we have already registered. So it's showing us the vote function. And let me create a new app here. And it doesn't register the vote yet because we haven't yet registered with this DAO. So I'm just going to show again, 1160 shows the vote because shows the vote buttons because we've already registered. 1185 shows register because we haven't registered yet. Excuse me. So I'm going to go ahead and click call register. And now at this point, we'll see that we've registered. So it sent the transaction, but we haven't updated yet, right? So it doesn't know that we've registered. So you have to do a very similar thing to what we did before. We're going to come down into our DAO register, and we're going to say set state equal to set state. And in DAO register, I'm going to define set state. This is going to be a function that returns a promise that is void. And then we're going to await props.setState. Okay, so now if we go through that process again, so create an app, call register. Now, after we've registered, it's going to update and call set state again. And in our set state, that's where we're getting the account asset information. So we're asking the ledger, does this account hold this asset? And if it does, register the vote buttons. And if not, we're going to set register to false, which will register the register button. And just to show that this is working, we can go ahead and vote like so. So that concludes the beginner portion of the bootcamp. In the intermediate, we're going to be taking a look at different storage solutions and how we implement those in our front end, in our tests, of course, and talk about how we can start addressing some of the problems that are with this current design, such as the exposure to simple attacks and the simple fact that anyone can vote multiple times. And we ideally want to limit that to 1 vote per person. So we'll be tackling those problems and building upon this exact same code base in the intermediate session. So if you're interested in that, tune in to either the intermediate bootcamp, which will shortly follow the beginner bootcamp, or just go to the intermediate bootcamp playlist on YouTube and follow along there. So I do want to mention that if you have any questions, be sure to head to our Discord. It's discord.gg/Algorand. I know that a lot of this content was delivered in a pretty quick pace. This content was delivered with the idea that you're somewhat familiar with web development already. If you don't fall into that camp and you're brand new to development, this might have been a bit quick for you and you might need some assistance, but that is exactly what we're here for. Again, discord.gg/Algorand. You can find myself, my colleague Ryan, and a bunch of my other colleagues there ready to answer questions. And we also have a bunch of community members in there that are happy to answer questions as well. So again, this concludes the content for beginner. We'll be continuing this exact same code base in the intermediate. And in the meantime, any questions or just suggestions for things you want to see in future boot camps, let us know on Discord.